Okay, so into this topology, we are trying to complete our MGRE lab, Akbar. Okay.
Okay, sir. Okay.
Our topic for today is to complete our MGRE lab. After that, we can focus on DM VPN implementation, dynamic multi-point VPN implementation. Okay, so let's do the basic configuration first. I'm trying to configure interfaces and towards R1, R3, and R4 from R1, R3, R4 towards ISP router, towards this R2 router. I'm trying to configure default routing to create reachability from one source public IP to another destination public IP.
Okay, sir.
This is site A branch office, so whose name is site A. Interface fast Ethernet 0/0 10.1.12.1. Mask, no shutdown. Let's create loopback interface. 1.1.1.1. Interface loopback 192.168 10.1. Show IP interface brief. Let's configure default route towards R2 10.1.12.2. Let's go to R2 router. So it's the same topology. So R2 is acting as a ISP router. 10.1.12.2 mask. No shutdown. Fast Ethernet 0/0 23.1. No shutdown. 1/0 10.1.24.1. No shutdown. Show IP interface brief. Let's go to R3. This is site B branch office. So host name is site B. 0/1 interface we are using. So 23.2. No shutdown. And yes, we can create two loopback interface here. So 3.3.3.3 mask. Interface loopback 192.168.30.1 mask. Show IP interface brief. Let's configure default route. So for any unknown destination, 23.1 is the next hop IP. Let's go to R4. This is site C. So host name is site C. Fast Ethernet 0/1 as per design. So 10.1.24.2 mask. No shutdown, and we can create loopback interface 4.4.4.4. Now interface loopback 192.168.40.1 mask. For any unknown destination, 24.1 is the next hop IP, 24.1. Done, our basic configuration. Let's let's verify. So from R1, from site A, I'm trying to verify my connectivity with 23 dot. This is site B public facing interface IP, and yes, I'm getting reply. Now ping 10.1.24.2, and I'm getting reply. Akbar, let's create our tunnel again. Okay, MGRE tunnel.
Okay, sir.
Interface, if you remember our configuration step, interface tunnel number. We can configure IP address for this tunnel interface. So I'm using 80.1. It's the same design, 80.1. Now tunnel source, yes, tunnel source is 10.1.12.1. For tunnel destination, we are using GRE multi-point. So tunnel mode, GRE multi-point. IP NHRP network ID, I'm using 1. Now IP NHRP map. Now what is tunnel IP? So tunnel IP is 192.168.80.2. And what is public IP? 23.2. Right? Remember this entry, Akbar?
Yes, sir. Yes, sir. Yes,
Now,
yes, remember, remember.
now I'm creating one more entry for R4 router, NHRP, map, and what is tunnel IP? So 80.3. 80.3. And what is public IP? 10.1.24. Let's go
Two.
to let's go to R3 side B branch office. Interface tunnel 2. IP address so 192.168.80.2. Mask. Now tunnel source. So tunnel source is 10.1.23.2. Tunnel mode GRE multi-point. Now IP NHRP network ID, I'm using 2. Now IP NHRP map. So what is I'm trying to map site A and site C. So how to map? Public tunnel IP is 80.1 and what is public IP? 12.1. IP NHRP map 192.168.80.3 and 24.2. Let's go to site C. Site C. Interface tunnel IP address for this tunnel interface 192.168.80.3 and mask. Tunnel source, yes, 10.1.24.2. This is no, yes, tunnel 24.2. Now tunnel mode GRE multi-point IP NHRP network ID. So I'm using 3 IP NHRP map. So I'm trying to map site A and site B. 192.168.80.1 and public IP is 12.1. IP NHRP map 192.168.80.2 and 10.1.23.2. So remember our implementation about this MGRE implementation in our previous session.
Yes, sir. I remember. I do remember.
So this is our tunnel, right? This is our tunnel. Let's verify our connectivity with tunnel interface IP. This is site A branch office, and I'm trying to verify my connectivity with tunnel 2. This tunnel IP we are using on R3. I have a reachability. Now 80.3, I have a reachability. Now, if you check your interface tunnel information, so yes, this is here you can verify multi-point GRE. Okay, you are not using only GRE, you are using multi-point GRE.
Multi-point GRE.
And this is your tunnel source IP and tunnel destination unknown. So for tunnel destination, yes, we have a mapping. We have a mapping in our configuration. Let me show you again.
Yes, yes. You have
Now
mapped
we
everything.
now we have a connectivity with only tunnel IP. So I can use any routing protocol. For example, EIGRP, so 192.168.80.0. So we can advertise our tunnel IP in protocol and then our LAN network. So 1.1.1. Now network 192.168.10.0 wildcard mask. No auto summary. Let's go to R3 router EIGRP10 network 192.168.80.0 wildcard mask. Network 3.3.3 wildcard mask. Network 192.168.30.0 wildcard mask. No auto summary. Let's move on R4. This is our site C branch office. Router EIGRP 10. Network 192.168.80.0. Wildcard mask. Network 4.4.4.4. Wildcard mask. Network 192.168.40.0 wildcard mask. No auto summary. Now, if you verify your neighbor table, EIGRP neighbor table, for example, here, show IP EIGRP neighbor. Akbar, can you hear me? So we are not
Yes.
receiving any neighbor table information. Why?
Yes.
Because multicast traffic is not allowed through this tunnel interface by default.
Mm.
Multicast traffic is not allowed through this tunnel interface by default. So how to
Huh.
allow multicast traffic? Let's go to text file. Okay, so now my point is what? Once you configure your tunnel, by default, multicast traffic is not allowed through this MGRE tunnel. Akbar,
Okay.
what
Yes,
you
sir.
can do, you need to allow multicast traffic. So here is a
Yes.
command. Here is a one command you need to add. This command syntax is what? Let me show you this command syntax. Let's go to R1 first. We can go in tunnel interface tunnel. And what is command? IP NHRP map, multicast. And if you type question mark, you have two options. You have two options. You can go
Mm.
with dynamic and you can go with specific
Specific.
IP. Specific
Yes.
IP. Dynamic option we can use when you are working with DMVPN implementation, when you have a client registration on hub. But right now we are not using DMVPN, so we have a static IP. Let's go to verify here as per our design. As per our design, we are on site A branch office. So I'm telling into this configuration, to this tunnel, I want to exchange multicast traffic with this IP. This is what?
192.
Dynamic
192.
option. Dynamic option, or you can verify here. Let me show you this text file. This is what? This is your public IP. This is what? Your public IP. So you can go to here and I want to exchange my multicast traffic with 10.1.23.10. I want to exchange my multicast traffic with 24 dot. Let's go to site B branch office, R3, site B branch office, and we can go in our tunnel configuration. Our tunnel number is tunnel 2. So interface, tunnel 2, IP,
And
NHRP, map, multicast. And I want to exchange my multicast traffic with 10.1.12.1 and with 10.1.24.2. You can see now you are getting a message. See,
yes.
EIGRP agencies. Now you can check first, show IP EIGRP neighbor. So you have one neighbor right now. You have one neighbor
Yes.
right now. Let's go to site C and we can go with tunnel configuration. Our tunnel is what? Tunnel 1. So we can add one more command into this tunnel, IP NHRP map multicast traffic. And I want to exchange multicast traffic with 10.1.12.1 with 23 dot. So now you can verify here on site A, for example, you can see you are getting a neighbor relationship message from 80.3, right? And you have two neighbors. If you have two neighbors, so you have complete reachability, you can verify show IP route. Then yes, you are receiving all the routes from R3 and from
Yes.
R4. So if you
Yes.
want, if you are verifying your route information, for example, connectivity, for example, 3.3.3 with source 1.1.1. Yes, I can communicate ping
Yes.
4.4.4 with source 1.1.1. But this is GRE tunnel, Akbar. This tunnel
Yes.
not secure.
Yes.
If you try to capture this packet information in between branch offices, so you can verify because it's not encrypted. Let's initiate some traffic. Let's generate some traffic. For example, 4.4.4. I'm trying to communicate with 1.1.1, and you can verify ISMP traffic. You can verify complete ISMP traffic. This is data payload. This information is what? Data payload.
Yes. It's showing our private IP address also.
Private IP,
And
public IP. Public IP is visible. Public IP is because it's a public IP. It's visible
yes.
for attacker, okay? But I'm talking about private IP,
Yes. Okay.
LAN traffic. So
Yes.
here we can implement what? MGRE with IPsec. Okay? MGRE with IPsec plus IPsec. I'm not configuring, I'm giving you an idea, okay? Because now you are familiar with how to configure IPsec with GRE tunnel.
Yes. Yes.
So you can follow the same step. Let me show you. You can follow the same step. First, crypto ISAR-KMP key CCIE address. This key, session key, I want to exchange with R3 and with R4. So what I'm doing, I'm using any address. I'm using any address.
Yeah.
Now you can create your phase one tunnel, crypto ISAR-KMP policy one, authentication pre-share, encryption, triple dash, and hashing MD5 and Diffie-Hellman group 2. Now crypto IPsec transform set TS ASP your triple dash ESP MD5. I'm not creating any interesting traffic entry, no ACL. So we can create a profile, crypto IPsec profile, IPsec profile, and profile name is what? Prof1. Set transform set what? TS. And remember this profile we can apply on tunnel interface, Akbar.
Yes. Yes, sir. Yes.
So I'm not configuring, I'm just giving you idea. Now you can configure your IPsec tunnel. Now let's delete all these configuration. Wait. And we can move for our next implementation. It's called DMVPN implementation, dynamic multi-point VPN. So the point is, what is the drawback of this implementation? This type of implementation, this MGRE implementation, Akbar. MGRE.
Sorry.
If you remember GRE concept,
GR is not encrypting the data. Also, we have to only use in the point to point GRE.
point to point, perfect. So we can
Yes.
go with MGRE if we have multiple branch offices. Okay. So
Yes.
yes, we can go with MGRE. And if we have multiple branch office and we are looking for GRE, for example, in that case, you need to create multiple tunnel, right? Multiple GRE tunnel, separate tunnel.
Yes, sir. Yes, sir.
So I don't want to create multiple GRE tunnel. That's why I can go with MGRE. But into this MGRE, the problem is what? I need to create this map entry. I need to create this mapping manually, right? Yes,
Yes.
I need to create single tunnel. No problem. Yes, wait, single tunnel. I need to create single tunnel, but the point is I need to create all the
Yes.
entries statically. This is our MGRE configuration. So I need to create this map entry. For example, if you have approx 50 sites.
Mm.
So if
Yes.
you are here on R1, you need to create 50 sites entry, mapping entry into this tunnel interface. Yes, no need to create 50 tunnel. In a single tunnel, you can map all your branch offices. But the point is, this task is a manual task, Akbar.
Henry.
Okay, we need to map the branch office manually. Again, you can go to R3, and you can create 50 branch offices entry in R3. Then you can go to R4. You need to create 50 branch office entry in R4. So it's a manual task, right? And
Yes, sir.
if you want to create a communication, you can see here into this MGRE implementation. If you want to create a communication, for example, this is head office, this is head office, and this is what branch office. Branch office 1 and branch office 2. Branch office 2. So if you want to create communication in between branch office to head office, then yes, you can go with mapping. Remember our mapping inside the branch office? You can go with this mapping. You can go with this mapping, right?
Okay, sir.
But if you want to create a communication in between branch office to branch office, yes, you need to create a separate mapping.
Yes.
Now we are looking for some dynamic process. Okay. Dynamic process. I don't want to create these entry manually. That's why I'm looking for DMVPN, dynamic
Yeah.
multi-point VPN. In dynamic multi-point VPN, here we have a scenario of hub and spoke. Here we have a scenario of hub and spoke.
Oh,
In
yes.
DMVPN, one router, for example, your head office will act as a hub router. And your
Okay.
branch offices, for example, this is branch office 1, this is branch office 2, you have branch office, for example, 3. So one head office is acting as a hub router, and these routers are called spoke router. This is what spoke 1,
Spoke.
this one is spoke 2, this one is spoke 3. Into this scenario, all spokes router, they will register with head office with this hub router. All the spoke router, they will send a registration request to hub router. All the branch office, they will send a registration request to hub router. And once they register, all the branch office, once they register with the hub router, now if they want to communicate with each other, no need to create a separate entry manually, Akbar. If
Yes, sir.
branch office 1 is trying to communicate with branch office 2, traffic will travel like this. Traffic will hit on hub router first, then hub router will redirect this traffic on branch office. So no need to create manual entry like MGRE, manual entry. No. So here, this is called what? Dynamic tunnel. This is what? Dynamic
Yeah.
tunnel. You can say dynamic multi-point VPN. Clear the scenario?
Yes, sir. Clear, clear.
Concept. Let's try to implement here. So please wait 5 minutes. I'm trying to power off all the devices and we can do our basic configuration again. Wait. Okay, so please wait. I'm doing basic configuration again. This is site A branch office. Host name is site A. Site A. Interface fast Ethernet 0/0. Let's move on R2. This is ISP router, so host name ISP 12.2. Akbar, can you hear me?
Yes, sir. Yes.
Let's take a break for 5 minutes, okay?
Okay, sir.
Start our DM VPN configuration. Okay.
Okay.
It's a 9:30, so let's continue at 9:35.
Okay, sir.
Hello, Akbar. Can you hear me, dear?
Yes, sir. Yes, I'm here.
Okay. Let's continue our topic. Let's try to finish our DMVPN implementation. Okay.
Okay, sir. Okay.
So in DMVPN, we have hub and spoke kind of topology. In
Yes, yes.
DMVPN, one router will act as a hub router, and the rest branch offices, they are acting as a spoke router. So what is the
Yes.
configuration of a hub router? Let's consider this R1 as a hub, this R1 as a hub router, and these branch offices, for example, R3 is a spoke 1 and R4 is a spoke 2 router. So let's start our configuration with hub R1, R1. So now interface tunnel is a command, IP address, I'm using 192.168.80.1 for this tunnel interface. Tunnel source, yes, tunnel source. Tunnel source is 10.1.12.1. This is tunnel source. Now, wait. Tunnel destination. Okay, this is text file. Let me check. Okay, this is a get VPN. This is the text file. Okay. So now you can go to R1. So command syntax is what? Tunnel source, then tunnel mode, GRE multi-point is a command, IP, NHRP, network ID. Network ID, I'm using one. Multicast command, I will configure later, okay? But I'm
Okay,
using
sir.
only this command syntax to configure this router as a NHS server. So into this design, this hub router is acting as a NHS router, next hop server.
Okay.
This is NHS server. Now these are what NHS client. So this is the configuration. This is the configuration for NHS server. You can configure tunnel. You can provide tunnel IP. Tunnel source is 12.1. Tunnel mode GRE multi-point. And we are not creating any kind of mapping, Akbar.
Yes, sir.
Yeah.
Yes.
Here we are only using network ID. That's it. Now
Okay,
let's
sir.
go to branch office. Let's go to spoke one. Let's go to spoke one, for example, R3, R3. And what is the configuration for spoke one? You can go to tunnel interface tunnel one. Tunnel IP 192.168.80.2. Mask. Now tunnel source, yes, tunnel source is 10.1.23. Now tunnel mode GRE multi-point, IP, NHRP, network ID. You can define any number here. I'm using 5. Now this is spoke 1 router. So what I'm saying to this spoke 1 router, your NHS server is what? IP NHRP. Command is what? NHS.
And,
IP NHRP NHS. And your NHS router is what? 192.168.80.1. This is your NHS server. And now we can create a mapping only with hub router. Okay. So
yes.
IP NHRP map. And what is tunnel IP? 80.1. And what is public IP? 12.1. And for multicast traffic, I'm creating manual entry. IP NHRP map multicast 10.1.12.1.
Only
Now,
with that, we have to create multicast. No need to
now,
put for everything
yes, this is what for multicast traffic, okay?
with the
Multicast
hub
traffic.
only.
Multicast traffic with hub router,
Hub
yes.
only. Okay.
And this is what NHS, with this command, you are telling what? With this command, you are telling this IP address is your NHS server. It means this spoke router is a this router is acting as a spoke. This router is acting as a NHS. NSC, next hop client. This is what? Client spoke
Yes.
one. And your 80.1, your 80.1 is acting as a server.
Server.
Now let's go to this branch office,
Router 3.
R4, R4,
R4.
and I'm creating entry. Interface, tunnel, tunnel 2. IP address 192.168.80.3. 80.3. Now tunnel source is 10.1.24.2. Now tunnel mode GRE multi-point IP NHRP network ID. Now IP NHRP NHS is 192.168.80.1. So I'm creating only NHS server entry, your hub router entry. Now IP NHRP map. So yes, I'm creating a mapping entry, but only with hub router 80.1 and 10.1.12.1. IP NHRP map multicast address, multicast traffic. I want to exchange with 12.1. Now if you go to R1 router here, if you go to R1 router and if you are using this command show IP NHRP map, show IP NHRP for example, you can see you are getting a message, right? You are
Yes, sir.
getting a registration request message from 80.2 as per our design.
80.3 also.
80.2, 80.2 we are using on
Yes.
R3 router. Here we have 80.2, right? Here we have 80.3, right? So you have a dynamic registration request. Type is what? Dynamic. With 80.2, dynamic registration request with what? 80.3. So you
Yes.
have, see, you create a registration request, you send a registration request from spoke 1 to hub and from spoke 2 to hub, right, Akbar?
Yes, sir.
But now, if you go to R3 side B branch office, and if you check here, your mapping, show IP NHR. If you check your mapping, so you have a mapping only with 80.1, right?
Yes.
Yeah. Okay. Now, in case, if I am trying to ping 192.168.80.1, I'm getting reply, right?
Yes,
But
sir.
in case if I'm trying to verify my connectivity with 80.3, I don't have entry. Okay, I'm here. I'm on spoke one
Mm.
router and I want to verify my connectivity with this tunnel IP.
Okay.
I have an entry only with this hub router, right? My registration is what? Only with hub router. This R4 is also registered with hub router, right?
Yes.
So now if I'm trying to verify my connectivity with 80.3, I'm getting reply.
Yes.
I'm getting reply. And if you check here again, show IP NHRP, you can see now this entry 80.1 entry is a type is what? Static. But this
Yes.
80.30 entry is what? Dynamic.
Dynamic.
So it's dynamically created.
Yes.
So now spoke to spokes, yes, they can talk to each other. But traffic is traveling via hub. Traffic is
Now.
going to hit on hub, then hub will send to the spoke.
Yes. Correct.
So hub is what? It's a centralized device. Now you
Yes.
can use your routing protocol for connectivity. For example, okay, let's go to tunnel interface first. IP, NHRP, map, and multicast. I'm using 10.1.23.2 and 24 dot. Let's configure EIGRP router, EIGRP 10, 192.168.80.0. Clear our tunnel configuration, Akbar. Clear our tunnel
Yes, sir.
configuration. This is protocol. This is only for reachability. But yes, we have reachability with tunnel IP.
Yes, sir.
R3 spoke 1 can talk to R4 spoke 2, right?
Yes. Yes.
So we can configure routing here for our basic connectivity. So 10.0 wildcard mask, no auto summary, Let's go to spoke 1 router, EIGRP 10. Now 192.168.80.0 wildcard mask and network 3 dot. You will see you are getting a neighbor relationship message, right?
Yes, yes, sir. Yes.
Now network 192.168.30.0 wildcard mask. No auto summary. You can receive some information. Show IP, EIGRP neighbor. You can see you have a neighbor table. This is our DM VPN implementation. Clear? Dynamically created tunnel.
Yes, sir.
Clear now, Akbar?
Yes, sir. Yes, sir. Yes.
Now we can focus on our next implementation, but not today. We'll focus on in next class. Okay. Our next VPN implementation is what? We can focus on a very interesting topic is called Get VPN.
Okay, sir.
Okay, Get VPN. Let's discuss this topic in next session. And you can connect on same time, Akbar.
Okay, sir. Sir, one more thing, one more doubt.
Yes, yes, Akbar.
Sir, you will explain the NAT T in the section?
Yes, it's a simple topic, no problem.
Okay, sir. Thank
NAT,
you very much.
yes, we can discuss, no problem. Next
Okay, okay,
is a
sir.
NAT traversal, okay?
Yes, because I have some doubt about that also.
It's a simple topic. I can
So far it is
I
clear.
can explain
So,
you in I can explain you in firewall scenario.
okay, sir. Now, halas, it is clear for me now. So far it is clear everything. Thank you. Thank you very much.
Let's correct in next session, okay? And I'm
Yes,
sharing
sir.
this session recording today. Bye, Akbar.
Okay,
Take
sir.
care, dear. Bye.
Okay, sir.
Bye. Bye, dear.
Okay.